And this question is given that a liquid in a beaker has a temperature theta at time at any time, let's say T, and theta naught is the temperature of surrounding. Then according to Newton's law of cooling, the correct graph between ln of theta minus theta naught and T is. So we know that according to Newton's law of cooling, the value of dt divided by dt is equal to a constant into the temperature of object minus temperature of surrounding. Over here, with respect to time, the temperature of object is going to change, so we can write this variable. So this is dt by t minus ts is equal to a constant into dt. Now we can integrate on both the sides. So on the left side, it is something like 1 by x dx, so it is ln of x instead of x, we can write it as t minus ts. And on the right hand side, and over here we can remember one more important thing. With respect to time, the temperature is going to decrease, so dt is not positive, dt is a negative value, so you can put a negative sign over here. So you can write this is equal to minus of c is a constant, and integration of dt is going to be nothing but t plus constant of integration, let's say I'm just writing it as c1. So the if you are drawing the graph between these ln of t minus ts and t, so the equation is something like y is equal to mx plus c. So the graph is going to be a straight line with the slope over here is negative. So we can write graph will be a straight line with a negative slope. So the shape of graph will be something like this. Between ln of temperature of object minus temperature of surrounding, and this question is represented by theta and theta naught and time.